Welcome to MRL. In this learning session, let us learn a few very important theorems on triangles. The first one is the midpoint theorem and the second one is the converse of midpoint theorem. Now let us understand the statement of midpoint theorem. In a triangle, the line joining the midpoints of any two sides is parallel to the third side and equals to half of the third side. Now what does that mean? It means that if you are given a triangle ABC, ABC is the triangle, D is the midpoint of AB, E is the midpoint of AC, DE is joined, then DE is parallel to BC and DE is half of BC. So that is the midpoint theorem. Now the converse of midpoint theorem states that in a triangle, the straight line drawn through the midpoints of one side parallel to the second side bisects the third side. Now what is the meaning of this statement? In triangle ABC given to us, D is the midpoint of one side, that is AB, and DF is drawn parallel to the second side BC. Then BF, that is DF, cuts AC at point E such that AC is bisected, or AE is equal to CE, or E is the midpoint of AC. So that is what is the converse of midpoint theorem. Now let us learn how to prove these two important theorems. Now the statement is already given here. It is already very clear to us what is the statement. So the statement is, in a triangle the line segment joining the midpoints of any two sides is parallel to the third side and one half of the third side. Now let us take the triangle ABC here. Let us take the triangle ABC here. P is the midpoint of AB, Q is the midpoint of AC, and PQ is joined. Now we have to prove that PQ is half of BC and PQ is parallel to BC. Now the construction required is extend PQ to R such that PQ is equal to QR. So we have to extend that PQ is equal to QR. Now and join CR. I have joined CR. So please remember the construction. Now the proof is, let us consider the triangle APQ and CRQ, these two triangles here. Now if you observe here, Q is the midpoint of AC, then AQ is equal to CQ, PQ is equal to QR, that is by construction. Angle 1 is equal to angle 2, that is vertically opposite angles, they are equal. Therefore, by side angle side congruency, these two triangles, that is APQ and CRQ, are congruent. If the two triangles are congruent, then the corresponding sides are equal, corresponding angles are equal. Therefore, we have AP is equal to CR, AP is equal to CR. And also, angle 3 is equal to angle 4. Now, if angle 3 is equal to angle 4, then AC is here the transversal. That means AP is parallel to CR. Please understand here, AP is parallel to CR. Now we have proved that AP is equal to CR and AP is parallel to CR, a very important step. Now P is the midpoint of AB, P is the midpoint of AB, AP is equal to CR, AP is equal to PB, and therefore PB is equal to RC, BP is equal to CR rather. BP is equal to CR. Now BA is parallel to CR because AP is parallel to CR, therefore BA is parallel to CR. So therefore now we have proved that BP is equal to CR and BP is parallel to CR. In a quadrilateral BCRP, BP is equal to CR, BP is parallel to CR, therefore BCRP, which is a quadrilateral, is a parallelogram, because we know that in a quadrilateral, if a pair of opposite sides are equal and parallel, then the quadrilateral becomes a parallelogram. So therefore BCRP is a parallelogram. If BCRP is a parallelogram, that means BC and PR are parallel to each other, therefore PQ is parallel to BC. And also PR is equal to BC because opposite sides of a parallelogram are equal. But we know that PR is 2 times PQ. We know that PR is 2 times PQ because we have constructed PQ such that PQ is equal to QR, therefore PQ is half of PR. If PQ is half of PR, we know that PR is equal to BC, therefore PQ is half of BC. So that is how we prove this theorem. Now let us learn how to prove the converse of midpoint theorem. The statement is very clear. The line drawn through the midpoint of one side of a triangle parallel to the second side bisects the third side. We are given a triangle ABC. P is the midpoint of one side, that is AB, and PQ is drawn parallel to BC. PQ is drawn parallel to BC, that is second side of the triangle ABC. Now we have to prove that PQ cuts AC in point Q such that Q is the midpoint of AC or AQ is equal to CQ. Now construction required is draw QR parallel to PB. Draw QR parallel to PB. Now in the quadrilateral BRQP we have PB parallel to QR by construction, PQ parallel to BR. That means BRQP is a parallelogram because PQ is parallel to BR, which is given, and PB is parallel to QR by construction. Therefore BRQP is a parallelogram. If it is a parallelogram, then PB is equal to QR and PA is equal to QR. That means we have proved that PA is parallel to. So please remember that PA is proved to be equal to QR. Now in triangle APQ and triangle CQR, angle 1 is equal to angle 2. Corresponding angles are equal. Angle 1 is equal to angle 2, which are corresponding angles. Okay, remember that, because AB and QR are parallel and AC is the transversal, and so also angle 3 and angle 4 are equal, again corresponding angles. Now the third angle APQ and QRC are equal because they are the third angle of the two triangles. Therefore by angle side angle congruency criteria, these two triangles are congruent. Okay, therefore by angle side angle criteria these two triangles are congruent, or even we can take AAS criteria. Now if two triangles are congruent, then corresponding sides and angles are equal, and therefore AQ is equal to CQ, or Q is the midpoint of AC, or the point Q bisects AC. So that is what is the proof of the converse of midpoint theorem. Two very important theorems, that is midpoint theorem and converse of midpoint theorem. So try to remember them, and they have their own applications in geometry. Make a note of this and learn. Thank you.